Okay, guys, today we're talking about compound inequalities. Now, a compound inequality is two inequalities combined by the word and or. Now, we got to pick our words carefully because they're going to be very important. And is very specific, and or is very forgiving. So if we say and, I need something to be this and also this, it must meet both conditions in order to work. If it says or, that's a little forgiving. I'll take anything that's greater than this or less than that. So when we use the words and or, they're very important, and we're going to have drastically different graphs. Now, the two graphs that we're going to look at today are the basic ones. Now, granted, we're going to be looking at special cases later in the week and into next week. But for today, this is pretty much what you're going to see. Now, a conjunction is connected. So we'll see this kind of barbell-shaped graph that goes from one value to another. In a conjunction, this is an and statement. Both conditions must be true in order to be graphed. Okay, the individual graphs must overlap at some point in order to be graphed. So this is the word and the mathematical symbol is this little upside down U that means and. Now, there's a couple of ways that you can see an and statement written. In our current example, it could have been x is greater than 95, intersection or and x is less than 98. Okay, it can alternately be written as since x is greater than 95, 95 is less than x. Okay, 95 is less than x. So we can write it all the way this way. 95 is less than x, which is also, and it's also less than 98. Okay, so pretty much every point in between these two values would meet this condition. Now, I'm just going to do a little drawing to show you that if I was ignoring this, I was just focused on this right now. Okay, x is greater than 95. Well, that graph would be an open circle at 95 and everything greater than that, everything heading in that direction. Okay, let me change the color now, I was only focused on x is less than 98. Well, x is less than 98. That graph would have been an open circle at 98 with a line heading this way. Okay? Now, let me see if I can get an orange. Where they overlap, these two graphs, x is less than 98 and x is greater than 95, overlap from 95 to 98, but not including 95 or 98. So we're saying any point that lies in this region correctly solves both of the inequalities at the same time. So if I picked the number 96, well, 96 is greater than 95. And 96 is less than 98. So the points in between here make satisfy both of these conditions. So each point meets both conditions simultaneously, but any point out here wouldn't work. So let's pick a different color. I'm going to use this here. If I set a point like 100, well, 100 is greater than 95. It met one condition, but 100 is not less than 98. Since it didn't meet both conditions, it's not going to be part of the graph. Okay, now let's take a look down here. In a disjunction, okay, these are going to be very simple. There's not much to these. Disjunction is very forgiving. It's an or statement. Any point that makes either inequality true must be graphed. Okay, they could either use the word or or this U, which means union. Okay, so they can use these interchangeably. The mathematical symbol will be a U, but you might just see the word or. Okay, I forgot to mention back here, you could see this intersection symbol, the upside down U, and that means and. You could see the word and, or when it's written all together, this is what's called an implied and. This is less than that and, or this is less than X, and X is also less than that. So it's all connected. It's an implied and statement. In an or statement, once again, you could see the union symbol or the word or. Okay, there's never going to be an implied or in this particular unit. When we get into absolute values, there will be, but that's for another day. Now here, this is saying we'll take anything that's less than or equal to 0, or we'll take anything that's greater than or equal to 2, but we won't take anything in between. Okay, so here we have in purple, less than or equal to 0. You would put a closed circle at 0 and anything in this direction, which is what was already graphed. Now, let's switch to green. Over here, we've got X is greater than or equal to 2. Greater than or equal to, closed circle at 2, line extended to the right. Okay, so in compound inequalities, we're always going to have at least 2 inequalities. They're going to be separated by one of 2 words. It could either be an and statement or an or statement. An and statement must meet both conditions. It must overlap somewhere. Okay, an or statement does not overlap. Usually will look something like this, where it's a disjunction. It's not connected. Okay, it's disjointed. So you'll have part of the graph going one direction, part of the graph going in the other direction.